Yeah, so at the bottom of page 358, I'm going to write down this powers chart, and then we're going to see how to use it for solving. I think you're going to really like the next set of questions that we solve. I'll pause this for now. Now, one of the things that you have been doing historically in math is solving for x. Like some of the very easiest solving for x things that you ever did was like, ooh. Right? You smile now, but that was hard at one time. Right? X is equal to 3. And then they were like, well, what happens if we put it inside a square root? Ooh, that might make it harder. And then they put x squared. Right? And you had to learn how to factor to solve those ones. And what we're going to get to now is putting the x in an exponent. And this one you're going to have no problem with. What's x? 2, right? And it would be even easier because you could go to, and this is a strategy we're going to use, is you could say, well, I know that 81 is 9 squared. It's pretty obvious what x is, that x has to be 2, especially if I write it like that. Right? I can make a really, really complicated question, one I can't even do the mental math in my head, but you can tell me what x is. If it's written like this, what does x have to be? 1.32. And that's going to be our first strategy as we go into example 1. If we can write powers on the both sides to have the same base, then the exponents have to be equal. But we're going to use all of our exponent laws from grade 9. So here we go, example 1. And our powers chart comes into play because we're going to look and see, is there a column in our powers chart that has the number 4 and the number 256? And the answer is yes. And actually the answer is yes in more than one place. If I go back to our powers chart, do you see that the number 4 and 256 is both here and here? Here's 4 and the 256, and here's the 4 and 256. So you have a little bit of choice here. You could either keep everything as powers of 4, or you could change everything to powers of 2. I'm going to keep them as powers of 4. In other words, on this side, I have 4 to the x, and 256 is 4 to the 4 from my powers chart. Now, what can I do with exponents on the bottom side of a fraction? I have an exponent law for that. Because my goal is to write both sides with the same base. How do you move this 4 to the 4 to the top of your fraction? A negative exponent law. What could x possibly be now? X has to be negative 4. So if you can get both sides with the same base, then the exponents have to be equal. All right. So it just so happened that 256 was on my powers of 4, so I could keep them as powers of 4. Is 27 in your 9th power chart? No. So this one we're going to have to look. In what column is both 9 and 27? Go back and scroll up. See in your powers chart, is there a column that has both 9 and 27? Here they are. They're in your powers of 3. So what we're going to do is we're going to take 9 and 27. I'm going to rewrite 27 as 3 cubed. There's still an exponent of x there. I'm going to rewrite 9 as 3 squared. And there's still an exponent of 2x minus 1 there. So go back to grade 9 exponent laws. An exponent to an exponent. If you forget an exponent law, go back to easy numbers, like 2 squared to the 3. What's the rule? Add, subtract, divide, guess. The guess is not. So this is a rule I've noticed sometimes on tests you guys use that rule, especially on multiple choice where you don't know. Just use the rule of guess and cross my fingers. Right? So you forgot what rule it is. By going to regular numbers, you can figure out the rule. Is it add, subtract, multiply, divide, guess, whatever you want to do? Well, what does an exponent mean? An exponent means repeated multiplication. So the cubed would mean this 3 times, right? And the squared, there's 2 of them here, 2 of them here, 2 of them here. I'm going to get 6 of them in total. What's my rule? It's definitely guess. Guess 6 and you got it right every time, right? No, it's multiply. We just need to multiply them. So here, I can apply that rule. It's going to be 3 times x. And here, it's going to be 4x minus 2 because I'd have to distribute when I multiply. And now, sometimes I even write, so it's obvious that the 3x has to equal the 4x minus 2. And now if I want to solve for x, I put my x's on one side, my numbers on the other side. X would have to be 2. What's that?
Like a test, right? If you were to just write the x, 3x equals 4x plus 2b, are you required to write so?
No, but we're technically not doing something mathematically here.
Yeah.
We're doing an observation that's obvious, but not a, mathematically on an equation, what you do to one side, you need to do to the other side. Okay? But you don't know what gets rid of that base of 3. Like, technically, we should be taking log base 3 of both sides, but we have no idea what that is yet. Right? So, I just put this here because I'm doing something by observation. You're not going to lose marks if you don't write so. It doesn't take very much to do. It's like 2 letters and 3 dots. I think you can handle it. So, all right, try questions, or circle questions 3, 4, 5, and 6. Do these feel more like math than graphing? I feel like this feels more mathy. You get an answer. I guess with a graph you get an answer. The answer is your graph. It just doesn't feel the same.